if you haven't already done so, you should do some research on what momentum is using the reading. You can also Google momentum or CK12 or use other resources like our textbook in class to help you with what momentum is. And then once you've done that, you're going to do a lab where you keep track of some notes about momentum in each case. So in each station, I'm going to have you make a prediction. So in the video, before I actually do it, you should pause and make a prediction about what you think will happen. I like to call object 2, whichever one is the stationary object in each case. And then here would be relative mass, which one is heavier or lighter. And then what's the velocity and direction before they collide? What's the velocity of object 2 before they collide? What's the velocity of object 1 after they collide? And object 2 after they collide. It's nice to show direction on here when you're showing velocity, so you can actually draw it as a vector if you want to. Truthfully, you could fill out all your predictions and all your relative masses and all your befores before you even continue with the video at all. So this would actually be a good time to pause the video and write down what you think will happen after the collision, what is going to be happening before the collision, and then you can watch my video to get the after. So this would be a good time to pause right now. And welcome back. I'm going to go ahead and just start with each one of these scenarios, go through them and show you what happens in each case. So in the first scenario, it looks like we have one that is stationary and one is colliding with it. And the one that is stationary, they're both identical masses. So I'm going to pick 2. Those would be similar mass. So I will roll to the right in each case. So I will push this way, and you can record what happens. So on your handout, you should have already made a prediction about what you think will happen when they collide. And you can already draw that this one's going to be moving relatively fast, and that one is stopped to begin with. And now I will show you what happens. It would be nice if this was a zero friction environment, but it's not quite. So you would get slightly different results. There it goes, in a zero friction environment. Okay, the heavy ball is stationary, and this one collides with it. So I will go ahead and do that. That's activity number, or station 2. Do that again. Okay, that should give you an idea. And this time the stationary one, light ball is stationary. I'll put my hand here to stop it from moving off the chart. All right, and then station 4 and 5 are going to be blocks instead. And the nice thing about this is I could actually reduce the friction quite a bit with straws. It may give you even a better idea what would happen in a zero friction environment. So station 4, I'm just simply going to roll one of these and have it collide with the other one. So if you haven't made your prediction yet, go ahead and do so. And now I'm going to go ahead and do it. One more time. Okay, and then the final station. So far, all of the ones that you've seen have been what are called elastic or semi-elastic collisions. The last one is what we're going to call a non-elastic collision. And when they hit, the Velcro will stick. Okay, so I'm going to repeat the experiment, but this time when they hit, it's going to run into the Velcro. So this is the last one, or station 5. Okay, so here we go. One more time. Okay, that should help you with your results.